Hi there, this is Barış Tezcan. I'm glad that I'll be presenting our work today with the presentation Disrupting Sex Trafficking Recruitment using Community-Based Resource Allocation Models. I'm a PhD candidate in Industrial Engineering at Northeastern University, and here's a list of my co-authors. This project is being funded by NIJ, and we are fortunate to work with the Survivor Advisory Board to include the survivor's point of view into the model's thinking and validation, and you can see the members of our board here. Our objective with this project is to better understand the recruitment dynamics in the sex trafficking context, so we can hopefully generate models that will assist with disrupting the recruitment into the sex trafficking. We aim to do this by mathematically representing the effects of disruptions on the vulnerabilities, and therefore recruitment strategies of the traffickers, so we can minimize victim exploitation. We know that vulnerabilities play an important factor in both recruitment prevalence and in the type of recruitment strategy. So one of our tasks is to identify vulnerabilities for potential victims and survivors. Then we aim to get a sense of how does the recruitment strategies of the traffickers change with victim vulnerabilities. If we can capture the dynamics between the vulnerabilities and recruitment strategies, this allows us to consider how we can actually disrupt the traffickers in the recruitment phase by allocating resources to possible interventions such as shelters, mental health access, and others. So mitigating these vulnerabilities will disrupt the trafficking intuitively. One consideration we aim to have is not just shifting the recruitment, but actually disrupting it. If we are not considerate of this, our disruption might shift the recruitment from one strategy to the other, and not actually will have the desired effect of reducing the recruitment overall. This work is broadly concerned with disrupting recruitment into sex trafficking. I will go into more details in scope and the specifics, but I want to talk a bit about sex trafficking and the recruitment. Sex trafficking is a form of human trafficking where the victims are sexually exploited. Literature and previous research by trafficking experts suggest that traffickers mostly exploit victim vulnerabilities in their recruitment strategies. For example, poverty, addictions, and being homeless can make a person more vulnerable to trafficking. And on top of this, traffickers can adjust their strategies in recruitment. So the connection between the vulnerabilities and recruitment strategies are strong. Also, we call a victim who survived trafficking a survivor. But unfortunately, re-recruitment is a possibility and sometimes a reality for some people. For example, a victim might become a survivor after being trafficked, but there might still be a chance for being recruited into trafficking, which is called as re-recruitment. So I've mentioned the high-level goals of the model, which is to aid resource allocation decisions, so recruitment is disrupted for sex trafficking, and we aim to do this by firstly capturing the sex trafficking recruitment process, and we do this by using an event-based macro chain. However, this process will change with some resource allocation disrupt the chain, and we want to capture that with changing the original transition probabilities into estimated ones to reflect the disruption. And our model goal is to minimize victim and survivor exploitation. And one way to capture that might be using various absorbing states. So we can measure how does the people leave the system in a desired way or not. However, this is still work in progress, so we're still trying to identify the right objectives. The chains we have will have the states that represent the current state of a victim or a survivor in terms of their vulnerabilities. Our transitions represent state-changing events, and they come with their respective probabilities. On top of this idea of states and transitions with probabilities, we are investigating how can we change the transition probabilities in the favor of victims and survivors with the interventions and goals that I have mentioned. These goals can broadly look like decreasing the chances of moving to a more vulnerable state or increasing the chances of moving to a less vulnerable one. The initial states are around three main categories: pre-trafficking, into-trafficking, and being a survivor. The top layer is dedicated to pre-trafficking, or for capturing potential victims' vulnerabilities and how they are changing among themselves probabilistically. These affect the recruitment strategies as a single trafficker can utilize that will eventually end up being trafficked. The last two layers of states focus on survivor vulnerabilities and changes in them. But now, differently, the survivors can be re-recruited, and this is one of the reasons we wanted to use the macro chains. We had a chance to go over this general approach with re-recruitment and vulnerabilities with the Survivor Advisory Group, and they have validated the approach and it made sense to them as well. To make things a bit more concrete, let's say a potential victim has medium vulnerability. This might be the case of not having secure long-term housing, for example, among many other things. Then an event might occur to lose the housing, and this creates a higher probability of recruitment for the trafficking. In the next event, we can observe recruitment and therefore trafficking. Then let's say the person becomes a survivor. However, there might still be some high vulnerabilities that might lead to re-recruitment. Now, some potential absorbing states for this can look like these. If we want to measure our system by how people will leave the system. However, this is still work in progress and it goes iteratively. So I'm just showing this as an example for the upcoming math model, as our objective function can be a function of absorption probabilities. Our goal is to identify these meaningful states of leaving the system so we can measure the disruptions we want to test. Let's look at absorbing state 1, which is A1. This state is for a pre-trafficking exit point for the system, and it denotes the cases where potential victim is not trafficked in general. A similar dynamic can be observed for the survivors as well. We are working on identifying such cases so we can measure the disruptions. Now, let's say we all agree on the state space and the transition probabilities, which is this very small illustrative example. So I can talk a bit about the math behind the idea as well. We'll have different vulnerability levels and 2 possible absorbing states. Let also you denote the probability of being absorbed at state 1, which is not being trafficked, given you start from an absorbing state T. And on top of this chain, we want to embed our disruption intuition to the model. And our model will consider multiple disruptions, but for the sake of brevity, let's focus on only one in this example and presentation. Say X denotes the amount of resources allocated to disruption. And we also know effectiveness estimates is a big gap in trafficking research. So we'll focus on how a possible disruption can address the vulnerabilities. And say this resource allocation will address some vulnerabilities, and in the medium vulnerability level, for example, shift the transition to the low vulnerability positively and to the high one negatively. A quick reminder here on how we calculate the absorption probabilities in Markov chains. For a state diagram like this, we'll usually solve this set of equations to calculate the probability of ending up in an absorbing state, given we start from an unabsorbing one. And for example, if we start from low vulnerability with 90%, we'll end up on the absorbing state 1, and 5% of the times of the probability of being absorbed from starting from the medium vulnerability state, which we can see on the left-hand side with the equations. And finally, we'll find the U vector below that shows the probabilities for going to the absorbing state 1 for each non-absorbing state. After solving that equation. So if the resource allocation will change some of these values, we need to make some of these values as decision variables as a function of the resource allocation. One way to do this is in a simple model like this, for example. We can have various objective functions that favor going into desired absorbing states, such as not being trafficked, which is like the example in here, but it might also have different forms such as weighted averages or with different vulnerability level focuses, or you might only like focus only on some of them. And we'll also have a system of equations in the constraints for calculating absorption probabilities and other sets of equations representing our beliefs on how would these transitions will change as a function of the resources allocated. One thing we'll observe immediately here is the bilinear terms of P times U's. And the good thing is Groby can now handle these automatically. And I wanted to show an example outcome for a model that's objective was to maximize the sum of absorption probabilities for not being trafficked. On the left-hand side, we see the initial case, and pay attention to the circle transitions, which will change as a result of the resource allocation. And this change is also affected in our objective function as well, which you can see below. And the takeaway of this idea is there will be some resource allocation decisions. They will change the transition probabilities, and we hope to embed this to a decision-making model where our objective function will capture the recruitment disruption. I've mentioned that we want to test this modeling idea on various objective functions where we measure how a potential victim or survivor will leave the system of sex trafficking recruitment. We also plan on including penalties or rewards for important transition probabilities to give an additional emphasis on the inner movements of the chain, rather than just checking like the exit points, for example. Also, different vulnerability levels could have different priorities in different communities, so they can be adjusted as well. And for the disruption dynamics, we'll focus on the relationships between the resources allocated. And survivors suggested that there could be a priority list for the needs of either potential victims or survivors, and some can be only meaningful after some others are addressed. For example, to make things a bit more concrete, mental health access can be more effective only if there is adequate shelter and food. also, on another point, different disruptions can affect the same transitions, which might lead to interesting mathematical modeling situations. A big part of this research is to populate such a model, both for the state space and the parameters, so we can have some meaningful insights. And this is not a straightforward task in the human trafficking context, as we lack large data sets where we can make estimates with the traditional approaches, either for like the parameters or some of the notions I mentioned. And lack of data in the trafficking domain is both in terms of prevalence and changes in the recruitment dynamics after disruptions. Also, what we know already can come from different and multiple data sources or populations, which creates another layer of consideration in the transition, like in using these data sets. And also, this is a larger problem than the issues it creates for populating a model. It also impacts the real life policymaking, as it hinders our understanding of the real problem. However, we still have an understanding and knowledge about the recruitment and vulnerabilities and the possibilities of what might happen after, thanks to the work done by the trafficking community. And for a problem like this, there won't be any perfect data due to obvious reasons. So while populating our model, we start by capturing the current knowledge in the trafficking domain for our purposes. And we aim to expand that knowledge if we can by interviews and survivor advisory board meetings. And then we aim to try out different interventions and objectives, as I mentioned, to get possible insights for policymaking. And the way we approach this problem of not having a pre-made perfect data set is kind of like this. It's an iterative process between the modeling team, math modeling team, and the social scientists in our group, where the modeling team identify data needs and get feedback from them, from the qualitative team. And the feedback can be in the form of responses such as, like, we know these things from our past work, they might be in the literature. We can use the advisory group's input to validate some of the assumptions or to collect additional data. We can conduct some interviews from stakeholders, and for the cases where we cannot necessarily do these things precisely, we will use a sensitivity analysis approach to create meaningful scenarios and to see how decisions will change under different scenarios. Here's a summary table with, for example, 3 of our questions in general topics. Questions are in more detail, of course, but I just like presenting the main topics here. For example, a question we had was about how to actually create buckets of vulnerability, and our roadmap includes using the results of our group's previous work and checking the literature. For example, when we consider a similar question now for survivors, we would also have the survivor advisory board as a potential data and validation source. However, for example, for the relationships between vulnerabilities and recruitment now, we aim to conduct stakeholder interviews and also use sensitivity analysis, as literature might lack the level of detail we want by itself. And in total, to populate such a model that I presented today, we came up with 19-20 questions, covering the model idea, state space, transition probabilities, the disruption effects, and the resources that would go into it. And we aim to create an insightful model at the end by following this approach. As a quick summary, with this project, we aim to identify and represent victim vulnerabilities and traffickers' recruitment strategies mathematically, so we can capture the sex trafficking recruitment process within a Markov chain, where we incorporate disruptions as changes in the transition probabilities. And we aim to see how to allocate resources that result these changes in the favor of victims and survivors, so the exploitation is minimized. And we believe this can generate useful insight in terms of resource allocation for mitigating survivor and victim vulnerabilities. And this was it. Finally, thanks for listening to this presentation and attending the session. Please reach out if you have any comments or questions about this work or human trafficking and network models in general, and I'll be glad to be in touch. Here's my contact information, and have a nice day.